we are going to present a minimalistic teaching model device for endoscopic retrograde cholangiopancreatography. Disclosures by the author none. Disclaimers by the author. List of ERCP equipment. These instruments are costly but part and parcel of ERCP unit. This is a list of the material used in the model. All the materials are very cheap and readily available in the ERCP unit. Technique. Use a comb base with hollow tubes replicating the esophagus, duodenum, and bile duct for realistic anatomical constraint in biliary cannulation. Utilizes the AOA, that is Axis Orientation Alignment, framework to instruct on proper duodenoscope elevator control and papillary alignment during cannulation. Enables advanced training with a specialized attachment featuring a simulated papilla, that is a onion bulb linked to an electrosurgical ground plate for needle knife Precut sphincterotomy. Fully fluoroscopy compatible, allowing simultaneously practice of endoscopic visualization and radiographic guidance with authentic equipment. Minimalistic design ensures tactile realism for key maneuvers. ERCP cannulation technique, mastering movements. Video 1. Understanding major movement, big knob rotation for proximity to papilla, small wheel for lateral positioning, executing minor movements, elevator control for precise targeting, sphincterotome tensioning for 11 o'clock alignment, visualizing optimal cannulation position with papilla at 12 o'clock, sphincterotome at 2 to 4 o'clock, advanced technique, needle knife Precut and Fistulotomy for difficult cases. Let's begin with a sketch animation of ERCP. The illustration is a cross-section of the papilla with the bile duct and pancreatic duct converging at its tip. In this minimalistic model, for the sake of simplicity, we will concentrate on the bile duct cannulation via the duodenoscope. Let us focus on the distal tip of the duodenoscope to gain an understanding of the various movements required for biliary cannulation. The distal tip features an elevator at the opening through which the sphincterotome emerges, loaded with a guide wire to facilitate cannulation. For the sake of clarity, there are several movements across papilla, categorized as major and minor. Let's focus on major movement. This represents positioning the tip closer to or farther from the papilla by rotating the main, that is the big knob. Let us zoom out to observe the right and left movement of the distal tip of the duodenoscope actuated by the small wheel. A rightward rotation of the small wheel moves the papilla to the left side of the screen, and a leftward rotation moves it to the right side. Now zoom in to examine the vertical movement of the duodenoscope tip. This motion is produced by torquing of the duodenoscope in conjunction with push or pull maneuvers. A clockwise torque combined with pushing the duodenoscope advances the tip more distally, while the reverse occurs when torqued counterclockwise and pulled back. This adjustment positions the papillary orifice in the upper quadrant of the screen. Now focus on the minor movement. Sphincterotome can be maneuvered up and down via the elevator. This movement assists in precisely targeting the papillary orifice. Another important minor movement involved tensioning the sphincterotome, thereby aligning it to the biliary axis at an 11 o'clock orientation. Finally, on the monitor, the papilla is displayed at a 12 o'clock position with the cannulating sphincterotome emerging between 2 and 4 o'clock. The tip of the sphincterotome equipped with a hydrophilic wire is directed towards the papillary orifice. When conventional method for biliary cannulation fail, one standard technique is the needle knife Precut, which aims to expose the common bile duct by deroofing the overlying papilla. The incision should always be made away from the tip of the papillary orifice to prevent post-ERCP pancreatitis (PEP). The incision may begin from top to bottom or vice versa, achieved by the precise movement of the elevator. Needle knife fistulotomy is another technique that aims to directly puncture the distended bile duct in the papilla for biliary cannulation. Minimalistic ERCP training model, biliary cannulation and Precut techniques, video 2. Assembly of custom ERCP training model using household items, demonstration of duodenoscope navigation and biliary cannulation technique, practice setup for needle knife precut and Fistulotomy procedures, hand-on training for endoscopists and assistant coordination. We begin with the assembly of the model within the endoscopy laboratory. All the materials have been listed on the previous slide. The model is assembled in a systematic step-by-step manner, marking the midline on the queen size pillow. A long tube constructed from the cardboard and reinforced with rubber bands measuring approximately 25 cm in length and 2.5 cm in diameter is affixed along the pillow's longitudinal axis, following the marked line to represent the esophageal pathway. A secondary short tube measuring 2.5 cm in length and 2 cm in diameter is positioned approximately 5 cm below the lower end of the esophageal segment and 2.5 cm to the left, simulating the duodenal pathway. A curved tube with the distal tapering and an internal diameter of at least 7 mm is embedded within the pillow so that it is tapered and is positioned below the duodenal segment, thereby mimicking a biliary duct with its distal tapered tip representing the papilla. The rule of 3 AOA, axis orientation and alignment, serves as the foundational principle for biliary cannulation, with the axis defined by the bile duct's trajectory. Orientation is established by positioning the distal tip of the duodenoscope towards the papilla, while alignment refers to the directional trajectory of the accessory emerging from the distal tip via the elevator of the duodenoscope. The duodenoscope is advanced through the tube and subsequently retracted as demonstrated. The large and small adjustment wheels of the duodenoscope facilitates precise orientation of its distal tip. Rotating the large wheel downward, that is clockwise, moves the tip away, whereas rotating it upward, that is anti-clockwise, directs the distal tip towards the papilla. The elevator mechanism is actuated vertically using the base of the thumb. Similarly, rotating the small wheel to the left, anti-clockwise, shift the papilla to the right on the monitor, while rotating it to the right, clockwise, shift it to the left. It is recommended that the rotation of the control knobs be executed with one hand rather than with both hands. While securing the shaft in position, the middle finger is employed to perform push-pull movement at the tip, while the thumb simultaneously rotates both the large and small adjustment wheels. Following this push-pull maneuvers and knob rotation, the tip of the curved tube, simulating the papilla, is positioned at 12 o'clock position on the monitor. Next, a sphincterotome preloaded with a guide wire is advanced while the elevator is fully elevated. Upon contact with the elevator, it is released and the sphincterotome is incrementally advanced in precise millimetric steps under the dialed visualization, with the elevator being released using the thumb as previously demonstrated. The tip of the sphincterotome is further bowed to align with the biliary axis at 11 o'clock position, after which the guide wire is introduced into the tube. The model is fluoroscopically compatible, allowing real-time monitoring of the instrument movement using the ERCP unit fluoroscopy. Biliary cannulation is confirmed via fluoroscopic imaging by verifying the guide wire's entry into the curved tube. We now proceed to develop a setup on the same model for needle knife precut and Fistulotomy procedures. The following materials are required for this setup. An onion bulb is pierced by the curved tube and subsequently a toothpick is inserted to simulate a stent, thereby facilitating the practice of Precut techniques. The setup is mounted onto the previous model, ensuring that the saline-soaked gauze pad remains in contact with both the onion bulb and the electrosurgical unit plate. This contact is confirmed by instructing the assistant to apply slight pressure over the onion bulb, ensuring a secure connection with the pad and completing the circuit. The electrosurgical unit is configured to the recommended settings for Precut procedures. The needle light is then introduced in close approximation to the onion bulb as visualized on the monitor. Instruct the endoscopic assistant to retract the needle and then reintroduce it with successive elevator elevations. This maneuver is practiced beforehand prior to initiating the Precut. To avoid perforation, controlling the depth of the Precut is critical and require precise coordination between the endoscopist and the assistant. As a team, both the endoscopist and the assistant may practice this technique repeatedly on the onion bulb by rotating it around the curved tube. For practicing Precut over a stent, a toothpick is inserted through the distal opening of the curved tube upon which Precut is performed. The Precut must be executed in layers, with the onion bulb serving as an appropriate substitute for practice. After each Precut, the incised layers are separated using the sphincterotome by releasing the elevator and advancing with the small control knob. This process is carried out on a bulky papilla until the underlying biliary epithelium with its characteristic salmon pink hue and bile is exposed. In this, the toothpick simulates the bile duct and successive Precut to expose it can be practiced accordingly. This provides a cost-effective and reusable ERCP teaching model that accurately simulates anatomical constraints, including the esophagus, duodenum, and the bile duct. This model facilitates both basic and advanced techniques such as needle knife assisted procedures while being fluoroscopy compatible and usable for repeated uses. Its design addresses gap in current training tools, offering realistic tactile and visual feedback for comprehensive skill development.